This is section 10.4.3. We're going to take a look at the law of cosines. So we're going to solve oblique triangles using the law of cosines. Now remember, to find law of cosines, you need side, 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 and side, angle, side. Remember we talked about the little infographic. It said angle, angle, side, angle, and angle, side, side, or side, side, angle. That's law of sines. If you have side, 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 and side, angle, side, that's the law of cosines. And so these are the standard form versions of the formula. Now, they're all just a slight tweak, but technically, this is really all you need to memorize. If you just know this one equation, just this one equation, you should be able to figure out the rest of the pieces. This right here is the missing side. These two values, the B and C, are the given sides that they have, and then this is always the given angle. So these are the adjacent. The B and C are the adjacent sides, like they're between the angles. So in terms, if I were to draw a triangle, let's say if I did A, B, C, what I'm saying is if you had side, angle, side, here's C and here's B, you're looking for A, right? You don't know what A is. And so you have your given angle here, and so the C and the B, those are your adjacent sides in between the angle, and then you're looking for that opposite side. Now, I could move the given angle here, I can move the given angle here, and so you get two other forms because of that, right? What if I wanted to try and find side B? What if I wanted to find side C? All I did was just switch B and A, or I switched C and A, but the rest of the formula basically is intact. Then what if I want to find the angles? Because this is when you get side, angle, side. But what happens if you get side, side, side? Side, side, side means you don't know any of the angles and you need to find an angle. So you need to begin the process of solving for these angles. Now these are them basically written out for you. If you're really good at memorizing things, great. If you're not very good at memorizing things, you should just solve one of these previous equations. So for example, I can solve for C here. I can subtract A squared, subtract B squared. So I get C squared minus A squared minus B squared. And then that equals minus 2AB cosine C. Then I can divide by negative 2AB. So that all cancels out. And then you could take cosine inverse to both sides. And so you get C equals cosine inverse of C squared minus A squared minus B squared all over negative 2AB. That you can just enter into your calculator. Or in this case, how did I get from here to here? I just divided the negative through. So then the negative disappears. So that turned to positive. That was a negative. That's a positive. And that's a positive, right? Like, that's basically what happened. And that's how you get the formula that's above. Just be careful when you input. You need to make sure that you have parentheses around the values that you're inputting, because you don't want to accidentally square that minus. When that happens, a lot of bad things happen. So we don't want that to happen. So here's an example. It says find the three angles of the triangle. So let's find the opposite to the longest side first. So I want to find angle C. Now, like I said, I can just use the formula. If that's easy to memorize, go for it. Or I could say C squared equals A squared plus B squared minus 2AB cosine of C. Right? The only thing that those are both C, the rest are the other missing sides. And I can solve for it. So I can subtract A squared, subtract B squared. I can divide by negative 2AB. And then cosine inverse to both sides. and then you solve for c. Like, instead of memorizing it, all you got to do is just memorize one formula and then write the rest. And so from there, you just plug the values in, simplify it. So I know that that's 117.3. I can do the same thing to finding angle B. Just plug in the values, simplify it, you get 26.4. And then 180 degrees minus the other two, you get your missing side there. So however you guys want to go about it, like I said, my recommendation is just memorize the formula, the a squared equals b squared plus c squared minus 2bc cosine a. Like, if you just memorize that, it's easy to just manipulate that. It's almost like the Pythagorean theorem. Let's look at this one here. Let's find all the other missing sides and angles. So side angle side. Because it's side angle side, I know I'm going to use the law of cosines. The first side that I have to find is going to be B. So I could plug everything in. I have, this is my C, this is my A, this is my angle B right here. So you just plug it in. Plugged in C, plugged in B, and then if I simplify that, I get B squared equals 98.20. Now, the nice thing about this is you can literally just enter this statement straight into your calculator. As is. You don't have to do anything fancy. I mean, if you have a one function, then you can. But like, if you just enter that into Desmos, your Delta Math calculator, just one giant statement. Make it easy. And then the last thing you have to do is just square root both sides. And if you do that, you're going to get about 9.9. Now that I have all three sides, I can use then the law of cosines to find the other angles. You can also now use the law of sines if you want, if you found that to be easier. And so if I just plug the information in for angle A, 180 degrees minus the rest. In the closing of today's lesson, what did we learn today? In this lesson, we talked about the law of cosines. And so what is the generic formula for the law of cosines? That's going to be a squared equals b squared plus c squared minus 2bc cosine a. And if you wanted to find b, or if you wanted to find c, you just need to swap it. So if I wanted to find c, I'm just going to swap all the a's and c's. So I get c squared equals b squared plus a squared minus 2ba cosine c. Like, there's an easy way to memorize it. This does conclude our lesson. If you have any other questions, please leave them in the comments.